Hello, everyone. Thank you to Nadia and Brim for inviting me to talk about the role of data science in advancing mine water management and stewardship. My name is Wenying Liu. I'm an associate professor at the Department of Materials Engineering at UBC. So just a few comments on data science. And data science and data analytics is only a tool to help you make informed decisions. And a simple random forest classifier is not a solution to all problems. What to monitor and how to interpret data depends strongly on domain knowledge or a deep understanding of the process in question. So the role of data in water management, and I'm going to talk about this from both the production and the environmental perspective. For production, I'm going to focus on water reuse recycling in mineral processing or flotation, and also in hydrometallurgical processes. From an environmental perspective, I'm going to focus on management of drainage from mine waste rock piles. And data collection and interpretation should be designed differently for processed water and for the environment. So this is a simplified view of a mine water system. And you can see the interactions between mine site water system and a local water system. On the one hand, fresh water is withdrawn from the local water system to the mine site. And on the other hand, water is discharged to the local water system. And you can see that water is used for production, mainly in a concentrator, including comminution and flotation. The product is concentrate, which is typically shipped offsite for smelting, or it can be processed on-site using hydrometallurgical processes. And tailings is generated and deposited in the tailings storage facility. So water can be discharged from a tailings storage facility. Here you can see a little picture of mine waste rock pile. So drainage from mine waste rock pile could also pose issues from an environmental perspective. So I'm going to talk about first flotation. This is the first example I'm going to talk about, managing water quality variation in flotation. So flotation uses a large amount of water, which could be an issue in areas with a limited freshwater supply, such as Australia and Chile. So the process uses water ranging from roughly 1.5 to 3.5 tons of water per ton of ore processed. So what are the opportunities here? Increase water reuse and recycling in flotation, and avoid concentrate production and directly processing ore by heap, dump leaching, or even in situ leaching. Or diversify water sources such as use of seawater and municipal wastewater. So what are the technical barriers to do this? The barrier is water quality variation, because water quality responds to climate conditions, reuse, recycling, and water treatment in the water system. And the water quality variation has a significant impact on the flotation performance. Here you can see just two examples here. You can see first is a conductivity variation in response to climate conditions or the amount of rain. And this graph shows the impact of water quality on chalcopyrite flotation. And this is the appearance of frost layer. And you can see that the appearance looks very different at different concentration bacteria in processed water. So how do we put different pieces of information together in order to manage this water quality issue. First, we have to understand or monitor water quality variation. So the process water quality different from for environmental purpose. The process water quality varies typically quickly and requires continuous online monitoring. So this is in terms of data monitoring, and the other relies on the other aspect of information, relies on domain knowledge. So we have to carry out a lot of laboratory experiment to understand the impact of water quality on flotation. Then these two pieces of information can be combined to quantify the risk to production, and also different management scenarios can be evaluated. So I'm going to use a case study to demonstrate how data can be used to manage water quality issues in flotation. And you can see this is a chalcopyrite flotation using water containing high concentration bacteria. And you can see here, this is water quality monitoring or total organic carbon concentration in water. And this is a histogram. And this information is converted to a frequency plot. And here is the bacteria concentration on the x-axis. And this is the water quality part. And the other part is the impact on flotation. And laboratory experiment are carried out to assess the impact of bacterial concentration on copper recovery. And you can see as the concentration increases, copper recovery decreases. And this can also be converted to copper output as a function of water quality. So this is the second piece of information, and these two pieces of information are combined to quantify the risk. So this is the risk plot. You can see the x-axis is a copper recovery, and the y is time exceeding. So what does it mean? Here, if just a random point here, you can see 80% of the time, the copper recovery exceeding 65%. And then here could be 60% of the time, the copper recovery exceeding probably here 68%, for example. And this is a risk plot, and the copper recovery is converted to copper annual revenue, and you can see a similar shape as the risk plot. So the second example that I want to talk about is copper heap leaching with seawater. The benefits is to avoid concentrate production and save fresh water and reduce tailings production. And our research has shown that using seawater is effective for leaching secondary copper sulfide or chalcocite. And there are still issues need to be investigated, such as the leaching of primary sulfide, chalcopyrite, which is the most abundant copper mineral, and what is the behavior of a diverse range of gangue minerals in seawater, and leaching residue change and the possible environmental impact. And we published a series of articles on this topic. And another example that I want to talk about is gold heap leaching with seawater. And we carry out a project sponsored by Barrick. The main purpose was to develop a non-cyanide ligand for gold leaching. And our research results has already shown that gold oxide can be leached in ferric chloride media, but there are a range of issues need to be solved. And such as we have to figure out a way to keep regenerating the oxidant for gold leaching, and the same issue whether seawater leaching changed the solid residue, and whether this has any unintended environmental impact. So the last example I want to talk about is use data to predict and manage mine rock drainage. And here is a schematic published in one of the articles written by Dr. Liang Ma, a collaborator of us from the National Research Council Canada. And this shows the correlation between drainage flow rate and weather for a full-scale waste rock pile based on neural network. So you can see here, this is just an architecture of the whole process. You can see the data, or the inputs are weather monitoring data, and the output is seepage flow rate. And inside is just the architecture of the neural network, and has an input layer. These are data from weather monitoring station, total precipitation, and mean temperature. So there's one hidden layer, and the output is converted to seepage flow rate. And not just the drainage quantity and also drainage quality. And these are data from Equity Silver Mine. And you can see this is the correlation between drainage chemistry and the weather for full-scale waste rock pile based on neural network. And you can see here, this is input here, total daily precipitation and mean daily temperature. And this is the output as acidity of the drainage. And you can see that the input is correlated with the output through developing a neural network architecture. So these are the 4 examples that I wanted to emphasize related with using data to using data in water management. And if you have any questions, and feel free to send me an email. And thank you for listening.